Ladies and gentlemen, welcome to the presentation. I am Sazz Rahman. I work for a Los Angeles-based startup called Spotter. Now, Spotter is one of the pioneering startups in the content creation industry. We closely work with YouTube content creators, and we help solve two of their major problems. Problem number one is like as you get certain following and you're trying to get to the next big project, whatever you're trying to make a video, and that video probably going to be a viral among your audience. So what would be your next big idea? So we help with them with the ideation as well as the research for the next big video project. And also, as a creator grows and has certain following, their production budget goes up. And for all the budget requirements, we also provide them a transformative capital from Spotter. So we can call us like a VC for YouTube content creators. Now, as we listen to the creators and they're understanding the pain and the problem, we came up with Spotter Studio. We launched it like a month ago, and it uses LLM with certain retrieval techniques to help ideate various ideas for your next video title, thumbnail, description, all the critical components that actually will contribute to the success of your video. To do a live demonstration of the product, I'll switch over. So for example, this is like your home page of our Spotter Studio. By the way, this product is publicly available. Anybody can sign up and test it out. So let's just say in the ideation phase, I want to type attending tech conference with attending tech conference with, I don't know, Jeff Bezos. Okay, so we hit it and we let LLM work on it. And you see like it is generating, given my retrieval and the bio of the creator, some possible YouTube title you can use for your YouTube videos. And those are typical YouTube style. And if you like some of it, you can then actually change the mood if you want. Then again, it takes the feedback and generates some more titles for you. And the more amazing thing is that we also, making it multimodal, we ask it to generate thumbnails for that. So with just one simple text string, like, okay, and it is creating the possible images that you can use for your thumbnails in the next video. And this cartoon artistic style is one of our choices we made. It's just giving you the many possibilities that you can have for your thumbnails. And you can see like Mr. Jeff Bezos, and along with the creator himself, how their picture can be aligned together, what could be the possible background, the color scheme. And let's just say I like this video and I want to change the expression to excited. Then again, it understands the objects and try to generate the next set of pictures. So with that, we help the creators ideate and iterate over thousands and thousands of videos just within a minute. And this is the output we give to them. So Spotter Studio, we always are trying to solve the ideation and research problem. And the next ideation problem comes from search. Now, because in the YouTube, you can always definitely search certain videos and YouTubes in the search bar, but then YouTube only will give you the videos you're most likely to watch. It's a recommendation algorithm, so whatever as a user you are most likely to watch, YouTube will only produce those results in front of the web page. But with this tool, we try to augment those results. As a content creator, you not only want to see like how your videos are performing, but also you want to see how similar videos uploaded by a competitor is also performing. So we also produce and generate certain extra metrics for the creators to see and watch. Now, with that context, understanding this search-related problem, we're solving and we're experiencing a problem called the pains of keywords-based search. Now, I'll go back to, yeah, so ideation phase. So if you search for certain context in a search bar, now think about a typical search, for example, 10 things you didn't know about finance. So this is a very specific urge or request where I'm making to the search bar. First of all, I'm asking it, okay, tell me something I didn't know. So something like not so common, not so general. And the second thing is like, tell me something about that is related to finance. Now, if you follow the lexical search, or if you implement the fuzzy search in your search project, then these are some of the results we're getting back. And it's pretty common that you see that I put in a word, 10 things that you didn't know about finance, and the top results came in and focusing on the word thing. And it totally missed the context of finance altogether because, thing is matching with the string thing, and also maybe some spelling variation, it is getting the fuzzy results back, but not necessarily the context of finance. And then we utilized Deep Lake version 4 as our vector search, semantic search algorithm so that we can produce better results. And for our choice of choosing a vector database, is that we are collecting and amassing billions of records from YouTube. Like we have metadata for billions of videos from YouTube that are being uploaded every day, being modified, getting different metrics, and we are collecting snapshot for them every single day. So given that scale, we are very sensitive to the cost of deploying such large-scale data in certain storage using certain compute, as well as how we're going to even search that scale of data using a vector search algorithm. So for us, we're very sensitive to cost to house that amount of data. So why we like Deep Lake ActiveLoop? It's because if you already use Deep Lake, or if you ever have a chance to use Deep Lake, it's very easy to install as a library, as a pip install. But then all your storage, all the embeddings that you can store, it doesn't necessarily have to be in a hot storage. It's totally scalable. You can put all your embeddings in an S3 bucket or any kind of cloud blob storage and use any compute of your choice to use the embedding and create the indexes and save it back into the S3 buckets. So that makes it entirely, truly serverless. Whenever we call it serverless, we mean that whenever we want to use it, we want to scale it up, and we get charged for it, that's totally fine. But whenever we don't want to use it, we can turn it off completely and just only get charged for the storage that we're using permanently. So this is the true meaning of serverless, and Deep Lake allows you to have that serverless capacity. Now, the other good feature that on Deep Lake we found is like you can index on non-embedding columns. So if you think of filtering based on certain metadata, that is possible on a vector data store. Now, if you try different other vector database offerings in the market, this is not necessarily always true, that you can always index a column that is not necessarily your embedding column. So in our case, let's just say 2 billion data sets. But we want to just query the videos uploaded this month. So we don't necessarily have to scan through all the videos that we have in our collection. We can put a where clause or a filter, implement a filter, and reduce our search space and perform a much faster, much better query within the smaller space. Deep Lake allows you to do that. So implementing the version 4 of Deep Lake and the same query that I initially showed you, like 10 things you didn't know about finance. On the right side, these are the results we got back with the cosine similarity values. And the top results that you can see is like 16 things you didn't know about US money. So if you closely notice, all of the results on the right side don't even have the word finance. However, it somehow relates to finance. So this is the context search we're trying to achieve. Like it will understand from our documents, from the embedding vectors that we put in there, like how closely the word finance is related to the other concepts. So the finance is related to the word money. So it got that with a high probability and high cosine similarity values. The second one is very surprising, and I'm impressed with that. The concept of S&P 500. So the S&P 500 shocking facts you didn't know. See, you understand the concept of the finance. The S&P 500 is related to finance as well, and also it is trying to jumble and shuffle the words, like the things you didn't know. So it's way much better contextual results, much more meaningful results that we can produce for the creators, and then we get meaning out of the millions and billions of data set we have simply by trying this vector data search. So what are the quantitative benchmark using deep lake at that scale? So on the y-axis is like, first of all, to give some context, this is a data set of 15 million rows. And of the 15 million, we are performing a full scan and asking to return 200 results. And on the y-axis, the cosine similarity values, and the rank is the number one rank, meaning that's the most contextual, and the rank number 200 is the least contextual. And as you can see, using deep lake and doing a context search, the cosine similarity values are dropping as expected. As you go further in your search ranking, the less meaningful your search results will be given the HNS-W index. But you can see that it's still, majority of my search results is still over 7.7, which is really great results if you think about it. So that means like if I ask out of the 15 million records I have, some meaningful, some contextual queries, then I get back most of my time some results that are cosine similarity value of 0.7, which is great. The indexing implementation, thanks to the active loop team, their brilliant engineers develop the indexing and the quality of results we get out of that. So because as a startup, we work with other competitors, the major competitors in the market, we found that Databricks came close in comparison to active loop, because Databricks also offers serverless offerings, as well as you can store your data in a S3 data lake, and you basically connect and query that data using Delta Lake as their offering. So pretty much Databricks can offer you the same thing, and we tried that just to have a comparison with the active deep lake. Now, what I like about Databricks is like it's very easy integration. You're already using Databricks for your all-purpose query engines or for your data engineering tasks. If you already are using their Delta Lake tables, then it's just as simple as pointing to the right column and it will create the index for you. And once the index is created, we found that the query is pretty much low sub-second query latency, very good. And also the third feature I like about is the change data capture is pretty common and very easy for Databricks. However, what we didn't like about Databricks is like it is not necessarily a serverless offering, a true serverless offering. Once you're able to create the index using Databricks, you're not able to turn it off and turn it back again. You have to wait 7 to 10 hours again to recreate the index. So that is not necessarily truly a Databricks or serverless offering as they're trying to promote. And of course, that's why it causes the ingestion pain. And what ActiveLoop offers us is the multiple columns. You can have multiple embeddings. This is not necessarily true for a single index for Databricks. So what we learned using ActiveLoop and all the other major competitors is like all the Databricks offering or the ActiveLoop friend, they're really great. They're offering great results. However, for our scale, we found great value using Deep Lake version 4. And of course, some of the major learnings we learned, like just because uh, there is a great database algorithm, it will always produce meaningful results, not necessarily. So there is always an opportunity to use RAG method, or the RAG method, or retrieval method to enhance or enrich your data. So in our case, along with the video title, if you could add more information about the creator's bio, about the information about the creator channel, we found better results simply because we added for the LLM model to have it with the retrieval model. So with that, I'd like to conclude. Thanks for joining.